Hello friends, welcome back to Smart Engineering Academy. So in this session I have planned to cover shear force and bending moment diagram. That means I am going to cover what is shear force, what is bending moment, and how to draw the shear force and bending moment diagrams. So this topics comes under strength of materials, that is SOM. Okay, this shear force and bending moment is basics of basics in our civil engineering. So without knowing this shear force and without knowing how to draw shear force and bending moment diagrams, you cannot solve and you will not understand anything in essay 1 and essay 2. Okay, this is the foundation. Okay, foundation for structural subjects. So here I had created some charts. Okay, simple charts. If you can follow the chart which I had prepared, you can easily draw shear force and bending moment diagram. So I had got many requests from my students to conduct a session on shear force and bending moment, so I had planned. So the main motto of the session is KPSC, Indian Engineering Service, and GATE. And also engineering students will have a good basics by studying this, by seeing this how to draw shear force and bending moment. So after conducting the session, we'll solve some of the GATE questions. Okay, we'll solve some of the Indian Engineering Service questions which has appeared in the previous year question papers, and mainly KPSC, Karnataka Public Service Commission. Fine, let us continue with the session. So what is shear force? Okay, before that I'll just take a body like this. Okay, if I act load like this, it undergoes compression. See, the direction of the load is here. So when you apply the load like this, the body deforms like this. That means the body gets contracted. Okay, this type of force is called as compressive force. Okay, this is compressive force, the force. Fine. Next one, if I take this some body like this, if I pull it like this, okay, which is against the body, okay, the body is going to get expanded. Okay, if this is the length L and this will be length L1, okay, the body gets expanded. This type of force is called as tensile force. Okay, now comes the shear force. So now comes the shear force. So what do you mean by shear force? Means, see, if I have a beam like this, okay, if I have a beam like this which is supported by two supports, okay, if I am acting a load over the air, some load over here, the resistance comes across here. So what happens? The section gets cut off. Okay, the force which is acting here, this type of force is called as shear force. Okay, be familiar. So what is compressive force, what is tensile, and what is shear force? Compressive force is just force is acted against the body and the bodies get compressed, it's called as compressive force. Tensile force is just the body is pulled, and this is shear force. Okay, so in definition we can tell it is an algebraic sum of vertical forces. Okay, so I told you this force, this is a vertical force. If it is a horizontal section, the section is horizontal like this, this is a vertical force. It is an algebraic sum of vertical forces. That means if I take a beam like this, just consider there are many number of forces, okay, many number of vertical forces. So here they are telling the algebraic sum of vertical forces either in the left or right of the section. What is left or right of the section? Means if I take a body, okay, if I cut in the center, this part is called as left and this part is called as right of the section. Okay, this is the algebraic sum of vertical forces either at the left or at the right of the section is called as shear force. Just know the difference between all these things, then it will be familiar. So the next concept is bending moment. Here I will assume the two cases. So just see here, in the first condition I had taken a simply supported beam. So these two are supports. Okay. If I assume a two conditions like this, here this is the first condition and this is a simply supported beam, and in this second condition I am just taking a overhanging beam. Okay, here what happens? See, these are two supports and one load P is acting over here. That at that time what happens? The beam is going to bend like this. Okay, in this case what happens? See, this is called as overhanging beam, that is the two supports are here and at the ends, okay, these two loads are acting here. Okay, in this type of situation what happens, the beam bends like this. Okay, so two types of curves we can see here. Okay, this is called as positive bending moment and it is also called as sagging. Okay, just to remember, you can take just it is a smiling curve. Smiling curve is called as sagging curve. So if it is bending like this in the upward direction, then it is called as negative bending moment. Then it is also called as hogging bending moment. Okay, for this hogging, the sad smiley, okay, it is smiling in the sad direction. Okay, the sad smiley is called as hogging and smiling curve is called as sagging. S for yes. Okay, this is just a shortcut to remember, just I am telling sagging. Okay, so when we come into the definition, the algebraic sum of moments, okay, same thing, the algebraic sum of moments either right or left of the section is called as bending moment. Okay, in case of shear force, what we had told, the algebraic sum of forces either at the left or right of the section. In case of bending moment, it is the algebraic sum of moments either at the left or right of the section. So what is moment? Moment I will just explain in the next future coming slides in a very detailed manner. Okay, just remember this: sagging and hogging, positive and bending. Smiling curve is sagging and the sad smiley it is hogging. This is just to remember. Okay, in some of the competitive examinations they may ask by giving this paper what is the type of beam. If they are giving and they will ask what is the type of beam, it is a simply supported beam. They may give this type of this figure and they may ask what is the type of the beam. So you can tell overhanging beam. Okay, so they may ask what is the positive bending moment and they will give some of the options, that is sagging. Negative bending moment is called as hogging. Sometimes they may give this figure also and they will ask the options. Okay, so friends, these three are very important things that you need to know. Okay, so first of all they have given roller. Roller is a types of supports. What are the types of supports? That means if I am taking this as a beam, okay, beam is supported by column or some supports. Okay, we need to know what are the types of supports. Okay, beam rests on a supports. Okay, so what are all the types of supports? There are many types of supports like hinged support, roller support, fixed support, etc. We need to know the details about what are the supports. So first one is roller support. Roller support means it is represented like this. Okay, the rollers will be given here. Okay, I'll just draw a beam like this. Okay, this is the roller support. So the roller support, the number of resisting force, that is the number of reaction R, is equal to 1 in this roller support. That means if I am acting a load like this, okay, this load is resisted by one reactions that is getting developed here. Okay, only vertical reaction is present. Vertical reaction is equal to 1 and the horizontal reaction is equal to 0, because in the horizontal reaction it is freely move. It freely moves in the horizontal direction. That is the reason why the rollers is been given here. But when you are acting a load, this load is resisted by this vertical load, so the total number of reaction is 1. So what about moment? Moment is equal to no such moments is developed in the roller. Okay, so direct hit shot question they may ask in KPSC, what is the number of reaction in case of rollers? Okay, one thing. So second thing, where the rollers is used? Rollers is mainly used in the bridges. Why? Next question is why the rollers is used in the bridges? That is because, see, in the bridges they will normally provide a concrete structure, concrete slab. Concrete, what happens? Due to the sunlight, okay, due to the sunlight, the concrete expands and shrinks. Okay, when the concrete expands, the rollers helps it to expand freely. Okay, in case if they have been given some fixed support here, what happens? Due to the expansion is resisted by the fixed support and it gets cracked. So that is the reason they have been given roller support, which helps in the expansion. While concrete is getting expanded, the roller helps in expansion. So I think you are clear with the roller support. Okay. So the next one is hinged support. Okay. In this hinged support, the number of reaction. Okay. The number of reaction is 2. This is also directly they may ask what is the number of reaction in hinged. That is one horizontal and other one is vertical. But what about moment? Moment is not there in types of hinged support. Okay, if you are acting a load like this, one resisting force. Okay, and in a horizontal direction also one resisting force will be there. Okay, either you can take it as VR, not an issue. Okay, one resisting force is developed here, and see, in this hinged support it is not able to move in the horizontal direction because the roller has not been given here. It is hinged, but since the roller has been given, it is able to move in the horizontal directions, which helps in the expansion and contraction of the concrete. So here horizontal reaction also restricted, and the total number of reaction is 2. Then coming into the fixed support. Fixed support is represented like this. Okay, so the number of reaction which is going to develop in the fixed support is 3. That is one vertical reaction, one horizontal reaction, vertical reaction, horizontal reaction, and other one is moment. Okay, so total number of reaction is 3. Just be familiar and be careful about this thing. This thing is very important in solving essay 1 problem, essay 2, and completely in strength of materials. It is the basic of the basics. Fine. The next concept is, while analyzing a structure, first we need to know whether the structure is determinate or indeterminate. Okay, there are 2 types of structures. Okay, there are 2 types of structures. One is determinate structure and other one is indeterminate structures. So how to find whether the structure is determinate or indeterminate? So I'll just take an example like this. I'll take one hinged support and other one is roller support. Okay, this is a beam. Okay, this is some structure. Okay, first you need to find how many number of reactions are present in a structure. I told you there is one vertical reaction for this hinge support and one horizontal reaction for this. So total number is 1, 2. And what about this? Here only vertical reaction. Okay, so total number of reactions in this structure is 3. This 3 is also called as external reaction or unknowns. External reaction or unknowns. So degree of static determinacy ds is equal to unknowns, unknown reactions minus known reactions. So what is the number of known reactions? The number of known reaction is 3. So what are the 3? One is horizontal reaction, one is vertical reaction, and other one is moment at x and y, something like that. So the number of known reaction is 3 and unknown reaction is 3. It will be 0. Okay, so this can be called as determinate structure. If the degree of static determinacy is 0 or less than 0, then it is called as determinate structure. If the value of this ds is greater than 0, then it is called as indeterminate structure. Fine, let us take one more example, that is one end is fixed and other end is hinged. So the total number of reaction is, and I told you in the fixed support there are total number of, one is vertical, one and other one is horizontal, and other one is moment. Okay, the number of reaction in the hinge is 3 and here is 2. One is vertical and horizontal. So the total number of reaction is 3 plus 2, that is 5. What is the number of unknown reaction? That is unknown reaction is 3. 5 minus 3 is 2. So degree of static determinacy is more than 0, then it can be concluded as indeterminate structures. Okay, in strength of materials we will study about determinate structure only. In this all the concepts we are going to study only the determinate structure. If you want to analyze the structure for indeterminate structure, it is we are going to do in SA1 and SA2. That is some moment area method. Okay, leave about that thing. First let us study what is determinate structure. That completes strength of materials, drawing shear force and bending moment diagram. These are basics of basics. Clearly understand everything what I had told in this slide. That is what are the types of supports and everything. It comes up to your SA2, up to you learn up to SA2. These things comes. Okay, fine. These are the types of beams. Okay, first one is cantilever beam. Cantilever beam means the one end is fixed and the other end is free. See, sometimes in KPSC examination they can ask the questions directly by giving the figures and tell what is the type of beams. Okay, one end is fixed and other end is free, is called as cantilever beam. See, this is the simply supported beam. Okay, two ends are and one, that is it is supported at the two ends and load is acting over here. Overhanging beam. See, one support is present here and number 2 support is present here. It is overhanging. See, in this figure we can see this is overhanging only on one side. If you can draw like this, okay, some load, this is overhanging on the both the sides. Okay, fixed beams, the two ends are fixed. Continuous beams means it is continuous, the supports are continuous. Okay, the cantilever beam is very important. And one more thing you just remember here, one end is fixed. Okay, that is proper cantilever. Now it is not required. Okay, just be familiar with these concepts, that is all the types of beams. So here I made some sign conventions. Okay, if you can follow these sign conventions while drawing the shear force and bending moment diagram, that is very useful. So this is the first rule. Second rule, I had given the directions, so I'll just tell you about all these things while solving the problems, then it will be easy for you to remember and understand. Okay, just do one thing, pause the video and write this chart in your some of the sheets so that it will be helpful and it will be easy. Okay, this sign convention is very important. If you can follow only these three rules, then drawing shear force and bending moment is very easy. Fine, I just taken an example. So my first question here is, what is the type of beam? The type of beam is simply supported beam. Okay, I told you this is a simply supported beam. Okay, so you came to know this is simply supported beam, and the first step while drawing shear force and bending moment is, first step you need to write the reactions. Okay, see, this is reaction at A. Okay, this support, and here I am writing this is reaction at B. Okay, at this support. Okay, first see here, the first rule what it tells, I have written the symbol like this. Okay, so this symbol is acting upwards. So see here, this symbol is acting upward, right? So I am just taking it in a positive. RA is plus RA, it is positive. Here RB, again it is acting in the upward direction. Though what is the upward direction? It is plus RB. Okay, so next, this, if the force is acting in the downward direction, then you need to take negative. So which is the force which is acting in downward direction? If we, according to the figure, that is W. So I will just write minus W, which is equal to 0. So this is the first step. First you need to see all the forces and their directions. If it is acting in the upward direction, then you need to take positive. If it is acting in the downward direction, you need to take negative. Then this I can write RA plus RB is equal to W. Then I need to find the individual reaction, that is what is RA and what is RB. To find RA and RB, you need to either make summation of moment at A also 0 or B also 0. Any one of the thing you can make it 0. I am just making summation of the moment at the point B. At this point, moment at this point B is equal to 0. Okay, this is the second step. Okay, after finding the reaction, I need to find the individual reaction. For that, I am drawing moment at B. Moment at the point this B is, I am making it as 0. And while drawing the moment, see in this solving the moments, we need to make use of rule 3. While finding the reactions, that is in this part, we have to follow the rule 1. And while finding the moment, we need to find the rule 3. We need to make use of the chart, which is third rule. Okay, this, what about the second rule? Second rule, to write down the shear force diagram. Okay, while to write down the shear force diagram, we need to make use of this second rule. For bending moment diagram, we need to make use of this third rule. And while drawing the reactions, we need to make use of the first rule, that is that you came to know we had already used. Okay, so now to find the individual reactions, we need to make summation of moment B is equal to 0. Okay, so while drawing the moment, see RA into this distance L. See, after finding out the reaction, that RA, we came to know RA is equal to W by 2. W is the load. RB is also W divided by 2. So the next important step is just draw the line like this, and in this line let us draw the shear force diagram. To draw the shear force diagram, you need to see the second rule to write down the shear force diagram. Okay, see here, if the load is acting upward, then we need to consider positive. So I'll just consider positive. That means I need to draw my shear force diagram upward. If it is in the negative means I need to go down, but my reaction is upward, and if it is upward, I need to go positive. Okay, this is the left of the section. This is right of the section. Right of the section, if the load is going upward, then we need to take it as negative. In the left of the section, I had given here that if the load is going upward, I need to take it as positive. So RA is how much? W by 2. I need to draw here, this distance is W by 2. Okay, and I can draw the straight line like this. Why I had drawn the straight line? Straight line is drawn because there is no load here, one thing. Second thing is there is no UDL. If there is a presence of UDL, then I would have written the line not in the straight line. So that I will tell you while drawing the shear force diagram for UDL. Just concentrate here. Just I am writing the straight line because there is no load here up to here. Okay, then see here, if the load is acting downwards, I need to take negative. It is in the left of the section. I am just consider this as the left of the section. I will just take. Okay, so how much I need to go down? That is up to W, the amount of load which is acting here, and this W. W means up to here, this is W by 2 and W by 2. W by 2 plus W by 2, the whole thing is W. Okay, are you understanding? I'm just making use of this rule. Since this is acting in the downward direction, this is also acting in the downward direction, so I need to go, how much I need to go down? The total load which is acting here, that is W, the total W I need to go down here. Then I'll draw a straight line. Okay, one more proof I can give you here is, see, in the right of the section we need to take in the negative direction, right? Negative means I need to go down. How much I need to go down? This is W by 2, I need to go in the downward direction, that is W by 2. Okay, either you can start drawing the shear force diagram from the left of the section, either from the right of the section. This is all about the shear force. First we had found out the reaction. After finding the reaction, we had taken the moment is equal to 0. We made a use of third rule and we found the individual reaction, that is RA and RB. Okay, with the help of RA and RB and also with the help of this second rule, we had drawn a shear force diagram. So the next ultimate rule is how to draw that bending moment diagram. That is very important concept. So while drawing the bending moment diagram in simply supported beam, just write one note. Okay, bending moment at supports is 0. Okay, in this line I am just drawing a bending moment diagram. Okay, and this is the note. At the supports, bending moment will be 0. Okay, at the load there will be some bending moment. Okay, so what is the value of this I need to find now. You know, bending moment is equal to force into perpendicular distance. Okay, so what I am doing is, I'll just make moment about the point C is equal to 0. Okay, moment about the point C is equal to 0. I am making moment about the point C is equal to 0 because I want to find the bending moment at the point C. Okay. Okay. Now to find the moment at a point C, either I can start from RA, that is from the left of the section, or right of the section. The choice is yours. Okay. This time I will start from right of the section. What is the right of the section? What is the reaction over here is W by 2, right? W by 2 into the distance up to the point C, because I had taken the moment at C is equal to 0. So what is from here to here? What is the distance? That is the total distance is L, and up to here it is L by 2. Okay, I'll just take L by 2. So the next question is, either I need to take here positive or negative. Okay, just come to the third rule, because I am drawing for bending moment or moment. Okay, so see here, the reaction is acting in upward direction, upward, or it is anti-clockwise, upward or anti-clockwise. What I had written here, upward or anti-clockwise, is positive, so I'll just take it as positive. Okay, so there is no other forces here, just I'll take which is equal to 0. Sorry, this is not bending moment at C is W by 2 into L by 2, that is W L divided by 4 is moment at C. Okay, so what is this distance now? This is WL by 4. Bending moment at the supports is 0, 0. So just draw a, okay, this will be your shear force and this will be your bending moment diagram. This is very simple. Okay, don't worry, we'll solve maximum number of problems, then you will come to know all the concepts very easily. Fine friends, that's all for the session. The remaining video will be updated in the next section or second part 2 of the video. In that we'll solve maximum number of problems and we'll solve the previously appeared questions which is appeared in the GATE, IES and KPSC. If you like the video, please subscribe to my channel, that is Smart Engineering Academy, which helps me to do maximum number of videos, and write in the comment board like any improvements is needed in the video and any queries and any other subjects that you people wanted. Okay, fine, thank you. Again, I'll meet you in the part 2 of the video. Thank you one and all. In that I'm going to solve many number of problems in simply supported overhanging and cantilever beams and everything. Okay, thank you, bye bye.